friends. Today, we are diving into the intriguing world of organic chemistry with a super cool tool called Lassaigne test. It's like the ultimate detective tool for sniffing out hidden elements like nitrogen, sulfur, and those elusive halogens in organic compounds. So, excited to unravel these mysteries together?
Imagine the 19th century time, brimming with discovery. In walks Jean-Louis Lassaigne, a French chemist. He comes up with this test, essentially a magic wand, that reveals the elemental secrets hidden in organic compound.
The magic behind Lassaigne's test is beautifully simple yet incredibly effective for catching elements like nitrogen, sulfur, and halogens in organic compound. And it's a heart. The test uses sodium's high reactivity to turn organic compounds into inorganic compounds like sodium cyanide if nitrogen is present, sodium sulfide for sulfur, and sodium halides for halogens. This transformation is a game changer because it makes the element detectable weren't in their original organic form.
So, we've decided to take thiourea on a little adventure for our next experiments. Now, to make sure our journey is a smooth one, we've got a list of essentials. We need some dilute hydrochloric acid, silver nitrate, ammonium ferrous sulfate, ferric chloride, sodium nitroprusside solution, ferrous sulfate, nitric acid, and of course 3 to 5 fusion tubes.
Start with a small hero, a piece of sodium. We heat it enough until it melts and disperses to us in vapors, signaling it's ready for the next act. We gently introduce our gas organic compound into the warm ingress of sodium. Add a bit more heat until it glows a salt red.
Repeat this process for 3 times with all fusion tubes.
Next, we give our mixture a splash into distilled water in a china dish, ensuring every bit of sodium narrative dissolves into the aquatic state, transforming into an aqueous solution. We turn up the heat to a gentle boil, brewing our potion. And then filter out the rest, leaving behind a clear, colorless treasure, the sodium fusion filtrate. This is not just a solution, it is the key to unlocking secrets of elements hidden within our organic compound.
Let's talk about how we can spot nitrogen in a sample using something called Prussian blue test. This is a pretty straightforward. You mix ferrous sulfate with sodium fusion filtrate, gently heat it up and then drop it in some concentrated sulfuric acid. If you see a Prussian blue or a green color, congratulations, you have got a nitrogen.
For the sulfur, we use sodium nitroprusside test. Take a bit of your SFF and add few drops of freshly made sodium nitroprusside solution. Look for the brilliant purple color. That's your sign for the sulfur is present.
Now, if you suspect your sample has both sulfur and nitrogen, there is the ferric chloric test. Add a bit of dilute hydrochloric acid to your SFF, warm it up, let it cool, and then add some ferric chloride solution. A blood red color means you will hit the jackpot with both sulfur and nitrogen.
Spotting halogens in your sodium fusion filtrate is doable with the silver nitrate test. First off, we got to make sure our SFF is clean from the stuff that might mess with our results. We'll add a bit of 5% nitric acid to it and give it a gentle boil for about 7 minutes. Why do this? Well, if there are any nitrogen or sulfur present in the mixture, this step helps to kick out any hydrogen cyanide or hydrogen sulfide that could have been formed in the reaction. After boiling session, let the solution cool down, then filtrate it. This leaves us with a prepped and ready SFF, free from any unwanted guests and set for the next phase. Add some sodium silver nitrate solution in the pre-treated SFF. Thus, formation of white precipitate indicates the presence of chlorides. A pale yellow precipitate suggests the presence of bromides. Yellow precipitate insoluble in ammonia solution signifies the presence of iodides.
Alright, Folks, let's decode what these colorful reactions are actually telling us in our chemistry detective work. If our experiment lights up with a positive silver nitrate test, we might be hanging out with alkyl halide, aryl halide, or even acyl halide. Now, if the ferric chloride test gives us a big thumbs up, then we are likely dealing with the sulfonamide, sulfonic acid, or thioamide. Getting a positive Prussian blue test is like unlocking a secret door that reveals our compound could be an imine, amine, or nitrite. And if the sodium nitroprusside test is all system go, then we have stumbled upon a thiol, thioester, or sulfonic acid. But hey, if none of these tests show anything exciting, don't worry. Our compound is likely a hydrocarbons or chilling with some oxygen containing compounds.
While Lassaigne test is valuable, it's not without its limitations. It cannot directly detect elements like oxygen, and the presence of multiple elements may require additional steps or tests for precise identification. Lassaigne test is like the Swiss Army knife of organic chemistry when it comes to spotting elements. It's straightforward but pretty sleek in how it works, cracking open the door to all sorts of deeper chemical insights. We really hope this chat has lit up some light bulbs for about how handy this test is. It's one of those classic toolkits in your science toolkit that once you know how to use it, you'll wonder how you ever did without it.